With his career in full swing and an international reputation emerging, Veerabhadran Ramanathan joined Scripps Institution of Oceanography in 1990 and set out designing his next field campaign. The 1993 Central Equatorial Pacific experiment took him to the region where ocean temperatures are hotter and the atmosphere more humid than any other place on Earth. Of special interest to climate researchers, the clouds here are among the thickest and brightest in the world. Scientists refer to this region as the Western Pacific Warm Pool. But despite the constant heat, something stops those temperatures from rising above a certain threshold. Ramanathan's expectation was that understanding the climate over this warm pool would give him a preview of the future, when the whole planet will have warmer and more humid climate. But it was in the midst of the experiment, known as CPEX, that he made an unintended discovery. The amount of sunlight that reached Earth's surface was significantly less than predicted by theory or models. Something other than clouds was acting to dim the sky and influence temperatures. To pursue this mystery, Ramanathan launched, with Nobel laureate Paul Crutzen, perhaps the most ambitious experiment of his career in 1996. Known as INDOEX, it was a multidimensional survey of the atmosphere over the Indian Ocean that would involve 200 scientists and a suite of aircraft, ship, and satellite observations. INDOEX demonstrated that aerosols such as dust or the soot from fires and diesel exhaust also act as change agents in the atmosphere. Their influence on climate is most pronounced in places like South Asia, where biomass burning is prevalent. Some aerosols, such as sulfates, are reflective like mirrors and cool the atmosphere as they deflect sunlight. What Ramanathan was surprised to discover, however, is that the reflective aerosols were accompanied by other dark particles that had the opposite effect. Tiny bits of black carbon soot rose from the chimneys of hundreds of millions of rural households throughout Asia, as well as from the exhaust pipes of diesel-burning vehicles, and gave the sky a brownish color because they trap and absorb visible sunlight. Ramanathan called large masses of these pollutants atmospheric brown clouds, or ABCs. These bits of black carbon particles that linger for short periods of time trap an enormous amount of sunlight. They amplify the warming from the planet's man-made greenhouse blanket. Ramanathan's work on these brown clouds confirmed what some climate models had predicted. Black carbon is second only to CO2 as the atmosphere's most powerful anthropogenic warming agent.
Finally, this body of work grew to the point where it was unchallengeable scientifically, and it was finally just sitting there as something, as a new avenue to approach climate change.
In INDOEX, scientists had recorded for the first time the dimensions of an aerosol cloud as much as 3 kilometers thick, that covered much of the subcontinent nearly year-round. Computer models had predicted this pollution would have an effect on climate, but INDOEX put a hard number to it. The soot dimmed the Earth's surface 10 times as much as had been suggested. At the local level, in especially polluted regions, Ramanathan found that certain short-lived climate pollutants cut down sunlight reaching Earth's surface by as much as 15%. And when soot and other pollutants fell from the atmosphere, they darkened pristine snowpacks and glaciers when they settled on the ground, making the frozen masses melt faster. The climate science community had great difficulty taking any of these phenomena into account before Ramanathan's experiments. The work caused the United Nations Environment Program to take notice.
He earned the further support from the UN Environmental Program when he took its director, the great gentleman Klaus Topfer, on an airplane ride, and they flew right up to the foothills of the Himalayas, and all the way there was the black cloud, and then finally they could see snow untouched. That sold UNEP, UN Environmental Program, and after that time they have given unbelievably strong support to his intellectual program to trace out the role of black carbon in the atmosphere.
The United Nations agency created Project ABC in 2002 to study the impacts of the pollution clouds. During INDOX, Ramanathan had found the perfect place to do so. The Maldives are a string of islands south of India. Though sparsely inhabited, the islands are often choked with levels of smog often found in sprawling cities. It is here that Ramanathan has returned frequently to study the brown cloud, most recently in March 2012. The islands afford researchers a unique vantage point to sample pristine air that comes from Antarctica just as it meets polluted air blown south from the continent. Ramanathan's team found that clean and dirty air masses collide directly over the small islands to make a smoggy atmospheric soup capable of altering Asia's climate. Over several field campaigns, Ramanathan tracked this exchange by making multidimensional measurements of clouds using small aircraft. The craft, called UAVs, recorded data above pollution masses, within them, and below them simultaneously for the first time. It was a revolution in the study of the atmosphere.
After he had done his ABC experiment, he realized that he was missing information about how the brown cloud was stacked up in layers above the ground. And he thought to himself, what I really need is a little fleet of airplanes.
We wanted to probe multiple heights in the atmosphere at the same time to see where the pollution is coming from and where it's going and how much heat it's trapping. So using this miniaturized unmanned aircraft, we were able to stack them in formation flying and look at them from above and probe them in the middle and see below what's coming through. So they provided a whole new way of looking at the atmosphere and understanding man's impact on climate.
This research, and all that had come before it, set the stage for what became a new pollution-focused climate policy in 2012. An estimated 40% of present-day global warming is due to black carbon and the other major short-lived pollutants. Ramanathan and his research team at Scripps showed in 2010 that by reducing the emissions of these pollutants with currently available technologies, society can reduce the rate of warming by as much as 50% in the next 30 to 40 years. This could help slow down the melting of Himalayan glaciers and Arctic sea ice. It could slow the pace of sea level rise. An international panel commissioned by the United Nations reviewed Ramanathan's findings. It not only supported them, but concluded that a reduction of the 4 pollutants could save the lives of as many as 4 million people every year, lives now cut short by respiratory illness and heart disease. In addition, 100 million tons of crop output lost annually to air pollution could be restored. By this time, Ramanathan had launched a new endeavor propelled as much by humanitarian concern as by scientific curiosity. Known as Project Surya, it reflected Ramanathan's growing desire to do more than just collect scientific data. The project would make clear that the issue was not just about climate change, but about saving lives.